The video for 2.3 area on the coordinate plane. So last class we did perimeter on the coordinate plane. Now we're doing area. So area is the total space taken up by a flat 2D shape. So going back to last class, if we had, pick your favorite shape. Perimeter was the outside, and we added up all the sides. Now area is how much space am I taking up on the inside. To do that, we'll need the area formulas. So that's these three. We will have the opportunity to count spaces again like we did last class. Like, you won't have to use the distance formula for everything, but it'll still be there. Okay, so counting spaces and distance formula again, just like last time. Instead of perimeter where we added everything up at the end, it depends on the type of shape we have now, because every shape has a different area formula. So rectangle is base times height, where base is the bottom and height is how tall it is. Parallelogram so is the same formula, base times height. However, a parallelogram is slanted. So when I say the height, I still mean how tall it is. I don't mean the slant. Not that. I want how tall it actually is. And base is still the bottom. Lastly, a rhombus, this one's the weirdest one. It's okay. Is 1/2 diagonal 1 times diagonal 2. Okay? We're going to go through each of these, although I'm probably going to skip through the distance formulas a little bit faster because we've been doing distance formula now for 2 weeks. Okay? There's your rectangle. I need to find the base, and I need to find the height, so that's going to be my long piece and my short piece. So I'm looking for I to j and h to I. And that's going to be two distance formulas. For I and j, it's going to be the coordinate points -6, -5, and 4, 1. And then for my height, that's going to be -6, -5 for I, and -9, 0. Okay, so you're going to use those, plug those into the distance formula. So that's calculator work. And we're going to get 2 square root 34 for the long piece, square root 34 for the short piece. Okay, once we do that, step 4 is find the area. So I found the base and the height. That's what the distance formulas was. Now I need to actually find the area, which is base times height, which is 2 square root 34 times square root 34, which when you plug that into your calculator, you get 68. Okay, I went through that a little fast. Try it on your own. That's a rectangle. Let's add one thing to the top here. For these, notice I got a pretty number. I got a whole number. Nice, pretty 68. Okay, that is because I did not convert to a decimal. You want the pretty number. Don't convert to a decimal. Ever. We're keeping it in radical form because we want the pretty whole number. Okay. Parallelogram is nice. You'll plot your points, and parallelogram is still, you need to find the base, you need to find the height, because that's my formula. But this is awesome because you'll notice here, we don't need to use the distance formula at all anymore, which is nice. Okay, we just need to think about this parallelogram as if it's sideways. We normally see parallelograms like this, where the bottom is the flat part. Tilt your head to the side. Pretend like the side WV is the bottom. That would be my base. And if I count that, which I can because it's horizontal, that's 7. Then my height is just going to be my tallest point to my highest places, right? Furthest I can get. This is 1, 2, 3, 4, 5, 6, also 7. And that's my height. Okay? Just needed to count. So think about the parallelogram like it's on its side and just count the base and the height. And once we have that, we multiply them together. So 7 times 7 equals 49. Again, a pretty number. Okay? A rhombus. A rhombus is a special kind of parallelogram, which is why it has a special area formula. Let's write it right here. 1/2 times, we're going to say D1 for diagonal 1, times D2. The question becomes, what does that mean? What is the diagonal? Okay, the diagonals are straight across through the shape. Okay, so I know the side lengths are also tilted too, but that's not what we're talking about. When we say diagonal, we mean diagonal through the shape. So for this particular one, it's going to be from U to W and V to T. Okay, and they're both slanted, which means we're going to use the distance formula. Okay, that means we're going to need all our points. And there's the bell. So I'm going to plug all of those in to my appropriate distance formulas, right? U to W, we're going to only want U and W. V to T, we're going to want V and T. Okay? When I plug those in, I get U to W is 2 square root 13. V to T is 4 square root 13. That's diagonal 1 and diagonal 2. So my final thing is finding the area. 1/2 times 4 square root 13 times 2 square root 13. Right? That's my formula. 1/2 D1 D2, 1/2 D1 D2. When I plug that into my calculator, I get the answer 52. Again, remember? Okay. Last is the triangle. Again, Delta Math is trying to make it difficult. So we're going to write the steps as we go because I forgot to print them. What we're going to do, step 1 is plot the points. Okay, you don't need to do that here. Step 2 is draw a rectangle around the triangle, like so. I need to essentially make 3 little triangles. Okay. Step 3 is I'm going to use this to find the area of all of my new stuff. Okay. So let's name the triangles just to make life a bit easier for ourselves. We'll say 1, 2, 3, and 4. Okay. Step 3 is I need to find the area of the rectangle, like the overall rectangle that I made. So base times height, that's 4 times 6, which is 24. I need to find the area of triangle 1, triangle 2, and triangle 3. So area of triangle 1 is 1/2 times 1, because that piece right there, whoop, it deleted. That's 1. This is 6. So 1 times 6. Recall from 8th grade. Sorry, I'm skipping around. Area of triangle is 1/2 times base times height. or if we want to say it a different way, base times height divided by 2. Okay, so that's what I'm doing here. Area of triangle 2 is 1/2 times, I see top is 3, side is 2, times 3 times 2, and triangle 3 is 1/2 times 4 times 4. So plug those into my calculator. This is 3, this is 3, and this is 8. So step 4 is, if I have all these areas, like I have the area of the whole rectangle, and I start taking away, all the other areas, I am left with the area of the triangle that Delta Math wanted me to find in the first place. So step 4 is area of the rectangle subtracted from triangle 1 minus triangle 2 minus triangle 3. Okay, so what that looks like is 24, because that's my whole rectangle, minus 3, minus 3, minus 8. So that's all the areas of my triangle 1, 2, and 3s. And when I plug this in my calculator, I get 10. Another pretty number. Okay. Try it out on your homework. Email me if you have any questions. Thank you.